Alright, so welcome to the 10th problem. This problem is going to be about enthalpy cycles, heats of formation, and we'll be using Hess's law. So the problem says the following. Use the enthalpy cycle below and the data given in the table to calculate the value of the enthalpy of formation for ethanol. This is the enthalpy cycle we are given, and we will analyze it further when we are setting up the equation. But we are also given numerical values for the enthalpy of formation of water, for the enthalpy of formation of carbon dioxide, and for the enthalpy of combustion of ethanol. So let's go ahead and solve the problem. The objective is to find a numerical value for the enthalpy of formation of ethanol. And for this, we need to be able to set up an equation that will allow us to yield this numerical result. And we need to use Hess's law for that. Now, Hess's law states that the enthalpy of combustion is equal to the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. Now, if we take this general law and adapt it to the scenario we're given, to the enthalpy cycle we're given, we're able to tell that the enthalpies of formation of the products are 2, right? So here we have that that 2 times the enthalpy of formation of carbon dioxide, because there's a coefficient of 2 in carbon dioxide, plus 3 times the enthalpy of formation of water, because there's a coefficient of 3 in the water of the products, that if we add those 2 quantities, we'll get the total enthalpy of formation of the products. So let's just go ahead and substitute those 2 in the parentheses part of the sum of enthalpies of formation of the products, as the cycle is telling us that it is these 2 that lead to the formation of the products. So we will have in this section 2 times, as there is a coefficient of 2, the enthalpy of formation of carbon dioxide, as is stated in this part of the cycle, plus 3 times, as there is a coefficient of 3, the enthalpy of formation of water, as it is stated in this part of the cycle. And that will give us the sum of the enthalpies of formation of the products themselves. Now, if we look at the reactant side, we can tell by looking at the cycle that there's only one enthalpy of formation that gives the reactants, right? So the cycle is giving us that there's 3 enthalpies of formation that affect this reaction, that take place, and 2 of them are going towards the product side, as we have already analyzed, and 1 of them is going towards the reactant side. So in this case, the sum of the enthalpies of formation of the reactants is just going to be the enthalpy of formation of ethanol, as it is present in the diagram, as it is displayed here. It's what the enthalpy cycle is telling us. So in this part, in the reactant, in the sum of the enthalpies of formation of the reactants, we're only going to include that 1 enthalpy of formation of ethanol for that. So once we have that, we can identify variables, right? So we now have an enthalpy of combustion of ethanol, an enthalpy of formation of carbon dioxide, an enthalpy of formation of water, and an enthalpy of formation of ethanol. Now, we want this enthalpy of formation of ethanol. So we need to isolate this in the equation. For that, we take it and pass it to the other side as a positive. So we have that the enthalpy of combustion of ethanol plus the enthalpy of formation of ethanol will equal the sum of the enthalpies of formation of the products. And then we can just take the enthalpy of combustion of ethanol out of that side of the equation and move it to the other to isolate the variable that we actually want. And in the end, we get the equation that the enthalpy of formation of ethanol is equal to the sum of the enthalpies of formation of the products minus the enthalpy of combustion of ethanol. Now, can we solve for the enthalpy of formation with what we have? Let's look at our table. Do we have a value for the enthalpy of formation of carbon dioxide? Yes, we do. It's negative 394 kilojoules per mole. So that variable can already be given a numerical value. Next one is, do we have a value for the enthalpy of formation of water? If we look at the table, we do as well. It's negative 286 kilojoules per mole. So that variable can also be given a numerical value. And lastly, do we have a value for the enthalpy of combustion of ethanol? And if we look at the table, we do have a value for the enthalpy of combustion of ethanol, which is negative 1,371 kilojoules per mole. So the three variables that we need to yield this enthalpy of formation of ethanol, we have values for them. So having that, we can just plug them in and solve it out mathematically. So we just plug the values from the table into the equation that we set previously based on Hess's law and based on the cycle that we are given, and we get that the enthalpy of formation of ethanol is 2 times negative 394 plus 3 times negative 286 minus negative 1,371. If we simplify all that, in the end, we have that the result is the addition of negative 788, negative 858, and positive, as the negative changes the negative within the parentheses, 1,371. If we add all that, in the end, we get that the enthalpy of formation of ethanol is negative 275 kilojoules per mole. And in that point, we will be done with the exercise, because that is exactly what the problem is asking for, to solve for that enthalpy of formation of ethanol, and we have already done so. So yeah, that would be the end of the video. Again, the presentation is linked in the description if you find that useful, and I hope you learned about enthalpy cycles. Thank you.